Hello everyone! Imagine you're in the kitchen and you need to make coffee. You can follow a precise recipe. Take 2 tablespoons of coffee, add 200 milliliters of hot water, stir for 30 seconds. That's one approach. Or you can learn through experience, trying different proportions, observing the taste, adjusting until you find your perfect cup. Completely different ways, right? This simple example perfectly illustrates what we're studying today: the fundamental difference between traditional system and AI-based systems. And believe me, understanding this distinction should change our perspective on testing as a whole. So, what exactly are traditional or conventional systems? Imagine a very detailed cookbook. Every step is explicitly written. If water temperature is above 80 degrees, add coffee. If user clicked submit, validate the form. In technical terms, traditional systems use imperative programming with constructs like if, then, else, and loops. The logic is predetermined, written by humans, follows a clear, predictable path. What feature of traditional system is particularly beautiful? It's relatively easy for us to understand how they transform inputs into outputs. We can literally trace the path. Input goes here, this condition is checked, that function is called, output comes out. Now AI-based systems, they're like that friend who makes amazing coffee but can't really explain how. Instead of following specific instructions, they study patterns and data. Here's a real example from the syllabus: an AI-based image processor for cat identification. Instead of programming rules like if it has whiskers and pointed ears, it's a cat, the system learns from thousands of cat images. It discovers its own patterns, perhaps relationships between pixel colors, shapes, or textures that we might not even notice. These patterns make testing AI systems a complex task for us. They're often invisible and non-obvious to us. The decision-making procedure becomes what we call a black box. Let's state this with formal definitions. Conventional systems. This is when logic is explicitly programmed by humans, predictable and traceable. And AI-based systems, this is when logic is learned from data, based on patterns and often opaque. Here's what's really interesting: the AI effect we discussed earlier also plays a role here. What we consider AI-based versus traditional can actually change over time. I like this example from the previous lecture. 20 years ago, a chess program capable of beating a human was definitely considered AI. Today, many see it as simply traditional software with very good algorithms. Now let's discuss why this distinction is important for us. When I test traditional systems, I can trace the code path and I can precisely predict what should happen with specific input data. But with AI-based systems, I can run the same test twice and get different results. And this might be completely normal. This means only that our testing strategies and even our very definition of correct behavior must evolve. But we'll discuss this later in subsequent sections. Here's a practical insight from my experience. In the real world currently, most modern systems are actually hybrid. They combine traditional programming for user interfaces, data processing and business logic with AI components for specific smart functions. Think about your smartphone's camera app. Regular code handles the interface and file saving, while AI manages scene recognition and photo enhancement. By the way, here's what amazed me when I first learned this. Some AI systems can detect patterns so complex that even their creators cannot fully explain how they work. There are machine learning models making medical diagnoses or financial predictions where the logic is more sophisticated than any human-written algorithm. It's like the difference between following a recipe and having an intuitive understanding of cooking that you cannot express in words. So, summarizing our kitchen analogy, traditional systems are like following a detailed recipe step by step. AI-based systems are like learning to cook through experience and developing an intuitive sense of ingredients and timing. Both approaches have their place, their strengths, and we need to understand how to work with both. In the next lecture, we'll discuss AI technologies, from machine learning to neural networks. We'll explore the tools and techniques that make these intelligent systems possible. Meanwhile, I suggest you look around and notice which system in your daily life follows strict rules and which ones learn and adapt. You might be surprised by what you discover. Thank you for your attention.